All right, so you guys should have your notebooks out. All right, so let's pick up where we left off. I know we didn't get to number 3 in this class yesterday, but we'll come back to it later if we have time. So let's start at number 4. So I'll give you guys a minute to write all 3 of these down. I'm going to have you guys do some of them on your own, and I'll do some of them with you. So just so you guys can get back in the practice of doing it from yesterday, I actually want you guys to do number 4 on your own, because I think you guys can easily do number 4. So remember, using the fundamental theorem of calculus, we actually take the integral, and then we evaluate f of b minus f of a. So I'll let you guys do that right now. Check with your table groups. If you guys want to use a calculator to check your answer so that you guys get practice doing that, you can do that as well. So take about a minute and a half, 2 minutes to do number 4. All right, so hopefully you remember that in order to do this problem, we can rewrite it without the x being on the bottom. We can just rewrite it with a negative exponent. So the 2/3, that's a constant. I can pull that out. And I can rewrite 1 over x squared as x to the negative 2 dx. So hopefully that helps us a little bit more with the power rule just to understand what we're working with. So remember, the power rule says you bump up the exponent by 1. So what's negative 2 bumped up by 1? Negative 1, and then divide by that new exponent. So we have 2/3 times x to the negative 1 divided by negative 1. And we're evaluating that from 5 to 10 using the fundamental theorem of calculus. Now remember, I'm not going to write plus c anymore because that plus c was only relevant when we were doing indefinite integration. But now that we're not doing that anymore, I'm not going to write it because remember, it always cancels itself out, just like we learned yesterday. So if I simplify this a little bit, I get negative 2 over 3x evaluated from 5 to 10. And then I just want to do f of b minus f of a. So you always start with the top one and then do the bottom one. If you subtract them in the opposite order, you're just going to get the negative answer. And so we definitely don't want to do that because a lot of times they'll put that answer on the AP test so that if you choose that one, you get it wrong. So make sure you always do f of b, the top number, minus f of a, the bottom number. So we'll plug in 10, so negative 2 over 3 times 10, minus f of a, so negative 2 over 3 times 5. And when I do that and I simplify, I get negative 2 over 30 plus 2 over 15. We should have a common denominator though, so let's get a common denominator. Negative 2 over 30 plus 4 over 30. So final answer would be 1/15. So again, just to refresh your memory, because it looks like a couple of you guys were good on taking the integral, but maybe the fundamental theorem of calculus from yesterday escaped your minds a little bit. So we have to take the integral first, and then we evaluate it for plugging in 10 first, the top number, and then subtract plugging in the bottom number. Can you guys tell me again why yesterday I told you guys to always put parentheses around the second one? Why did I put extra parentheses here? Yeah, so here on this case it might not have been that difficult because there's only one term here. But if there were more than one terms inside of this part right here, a lot of people will forget to distribute the negative. So I like to keep it in parentheses so I do not forget that. All right, for number 5, we could do U substitution if we wanted to. But what's another way we could solve this without having to do U substitution? Foil it. Good, so foil it. By the way, I saw a lot of people, when I had you guys do your test corrections, your justification, you put that you multiplied it out. All right, or not multiplied it out, I'm sorry, factored it out. This is already in factored form, so when you multiply it together, you're not factoring it, you're actually multiplying it. So good, you can either say you can FOIL it out or multiply it. So I'm going to let you guys try this one on your own. Multiply out 2x minus 1 squared, and then take the integral of it and use the fundamental theorem of calculus to get an answer. To the integral. You could take like almost like it's 3 separate integrals. All right, so check up on the board to make sure you did the integral correctly. So if you multiply it out and take the integral, you're getting a cubic function because we had a quadratic function. And then if you plug in 1 to all of these, you don't actually have to really write it out. You could probably just plug in 1. I like when we get to plug in 1 or 0 because most things either are themselves or go away. So if I plug in 1 to all of these, obviously nothing changes. So it's still 4/3 minus 2 plus 1 minus, and look how I'm putting parentheses around this because I don't want to forget to distribute that negative, and I promise you, I'll say it as many times as I possibly can because I promise you a ton of you guys will make that mistake if you don't put those parentheses. So minus, when I plug in -1, I get 4 times -1 cubed over 3 minus 2 times -1 squared plus -1. So from here, it's just simplification, making sure you guys don't do anything in terms of errors or adding or subtracting, but hopefully it's not too hard. I like to add my fractions last just so I can try and keep track of everything. So I have 4/3 minus 1 minus, let's see what's inside these parentheses. -1 cubed is a negative again, so that's -4/3. -1 squared is a positive, so that's -2, and then -1. If I keep going, and I'll keep going over here so I have extra room. I have 4/3 minus 1 minus -4/3 minus 3. So that's 4/3 minus 1 plus 4/3 plus 3. So that's 8/3 plus 2. 14/3. So, hopefully you guys all got up until the point where we needed to do the integral. After that, I know it's unfortunate, and I know this is like supposedly the easiest part. This is the only part that doesn't require any calculus, but this is the part that you guys will probably make the most mistakes on. All of you guys are really good at calculus, but for some reason you suck at algebra. No, I'm just kidding. That's a joke. You're great at algebra as well, but it's very easy to make mistakes in algebra is what I mean by that. So this arithmetic is almost like 90% of where people will make their mistakes. You guys are really good about actually taking the integral, just actually simplifying. So just be very careful on all of my tests as well as the AP test, just because we don't want to make any mistakes unnecessarily. So I know that you guys are rushed for time on tests, but do your best, especially when you have a lot of arithmetic like this, to make sure you're very careful with your signs, make sure you're very careful with your adding and subtracting to not make errors, to not make mistakes. All right, let's look at number 6 together. How in the world are we going to integrate that? Ideas? I hear move x to the top, so let's try that. All right, if I move x to the top for number 6, I get the integral from 1 to 8 of x minus 2 times x to the -1/3 dx. So I move it to the top, that's the negative exponent, and instead of writing it with a radical over it, a third radical, I just change that to a fractional exponent, if that's okay with you guys. All right, somebody else, how does that help me? What can I do now? I hear U substitution. I'll give you a major hint. You don't know this yet because I haven't told you. But U substitution for definite integrals like this using the fundamental theorem is a little bit different. So that's actually what we're going to talk about later this week. So we can't use U substitution yet because you guys don't know how to do it. Not technically with definite integrals. So how else could we do it? Distribute. Great. Let's distribute that x to the -1/3. So if I distribute it, I get the integral from 1 to 8 of what? What's x times x to the -1/3? What do I do with exponents when I'm multiplying? I'm adding. So x to the first power and x to the -1/3, if I add those exponents, would be x to the 2/3. And then -2x to the -1/3 still. All right, let's see how well you guys can take the integral of that. So go ahead and take the integral of that, and then evaluate for the fundamental theorem of calculus. Looks like most of you guys have your integrals so far, so check up here for your integral, make sure you got it right. And then evaluate it. So plug in 8, plug in 1, and subtract them. All right, how comfortable do you guys feel doing fractional exponents in your head? Like, how comfortable do you feel evaluating 8 to the 5/3 in your head?
Like a 4 or 5.
Like so-so? Okay, so let's do them together. So even if you're not done yet, that's okay. I just want you guys to get practice doing these in your head and actually feeling comfortable with them. So put down your pencils for a minute, and you guys are going to help me do these in mental math rather than on paper. So look up here. And let's talk about 8 to the 5/3. Now, in my opinion, because 8 to the 5/3 essentially means take 8, raise it to the 5th power, and then cubed root that, right? Now, I don't think, I mean, you guys might be super geniuses and I'm not, but I don't think many of us could figure out what 8 to the 5th power is very easily in our heads, could we? Probably not. So in my opinion, it's easier to make a number smaller before we make it bigger. So, what is 8 to the cubed root, or in other words, the cubed root of 8? 2, so that's making it smaller first, and I think it's much easier to take 2 and raise it to the 5th power. So what's 2 to the 5th power? 32. So that is what I want you guys to practice doing in your head. So this is really 3/5 times 32. Let's try the second one. We have 8 to the 2/3. So again, this one's not as difficult. It's easier to raise 8 to the 2nd power, but let's still make it smaller first. So what's the cubed root of 8 again? 2, and then what's 2 squared? 4. So this is 3 times 4. And again, without a calculator, because again, this would be a non-calculator question on the test. So without a calculator, you need to be able to do that without the use of one, I should say. So when we multiply this, we get 96/5 minus 12 minus 3/5 plus 3. So that's 93/5 minus 9. Is that right? Did I do my math wrong? Okay. So if I get a common denominator, I have 93/5 minus 45/5 equals, what's 93 minus 45? I'm asking you because I don't want to do it. 48? 48/5. Now, on the AP test, I don't think they try a lot to do problems like this where it requires a lot of arithmetic because they understand that this is a calculus test, not an arithmetic test. And so because of that, there might be some, but not a lot of them. So it's not like you should expect a lot of questions to be like, do this little tiny bit of calculus and then do all of this arithmetic, because it's so easy to make a mistake over there that they try not to put those questions on there because they really want to know, do you know what calculus is, not do you know how to add fractions together. Obviously it's important and you should know how to, but they also understand that with the time crunch that it's easier to make mistakes, so not a ton of them have these long drawn out types of questions to them, which is nice. It's nice for you guys, I should say. Alright, I think you guys probably feel pretty comfortable with the fundamental theorem. It's just taking integrals and practicing that we've been doing. So I do want to do a couple trigonometric ones just so you guys can get practice with those as well. So let's actually skip over 7 because I think you guys can do 7 pretty easily. Let's do number 8 together. So write down number 8. And again, I think you guys know how to take the integral of this. So take the integral of 4x plus secant squared of x. If you don't remember your integral rules, go look in your notebook and find that paper I gave you.
Yeah, exactly.
So 0 over 1.
Wait, 0 over 1? Is it 1 0 or is 0?
So it looks like most of you guys are pretty good about getting 2x squared plus tangent of x is the integral. From 0 to pi over 4, I heard a lot of you guys debating on what different evaluations of tangent were. So hopefully we all got these correct. So tangent of pi over 4, then minus. When you plug in 0, that first term goes away, and then we have minus tangent of 0. So let's talk about them in terms of the unit circle, because that's probably what's going to help us out the most. If we look at the unit circle, I'm actually only going to look at the first quadrant. This is the point what? 1, 0. And I'm only going to look at pi over 4. So pi over 4 is what? Root 2 over 2, root 2 over 2. All right, beautiful. So when we evaluate this, I get 2 times pi squared over 16 plus tangent is sine over cosine. So root 2 over 2 divided by root 2 over 2, what's that? 1. So plus 1 minus tangent of 0 is sine over cosine. So what's sine over cosine here? 0. So when we simplify this, we get pi squared over 8 plus 1. Final answer. Raise your hand if you got that. Okay, some of you guys probably got close to it and maybe just didn't get exactly, and that's okay. Anybody else need this? All right, beautiful. All right, we're going to do one more before we finish this up for today. So let's look at number 9. Now, I want you guys to talk about number 9 first to see if you think you know how to do it, and then I'll tell you the way that I would do it if I were you guys. So I'm going to say 30 seconds. I want you guys to discuss number 9 together. All right. Talk to me. What do you think about number 9? Yeah, go ahead.
Maybe like how in algebra, how you could pull out 2 absolute value functions, like we do at the same
You could. Would you know where to break it apart? Okay. So are you talking about like if you had 4 minus 2x equals 3 and then you could do 4 minus 2x equals 3 or 4 minus 2x equals negative 3, that kind of thing? Okay, except we don't have a number for what it equals yet, so we don't exactly know that. Other ideas? So we need to figure out something about the absolute value. I heard a couple people whispering like, oh, isn't it just like parentheses? Could you just take the integral normally? And the answer to that is not quite, just because the absolute value is a little bit different than that linear function. So here's my question to you. What does the absolute value function look like? The parent function of absolute value? Like a v. What kind of, well, I don't know, without trying to lead you guys on a wild goose chase. The lines of absolute value are straight lines, correct? Okay, this whole week, before we just started getting into this fundamental theorem of calculus, we've been talking about how to find the area under a curve with straight lines. We could just break it up into rectangles and triangles, okay? It's probably easiest if you do that here as well. So literally draw the function, draw 4 minus 2x, the absolute value of it, and then just find the area of those triangles or rectangles or whatever they are. So 4 minus 2x, would you know how to draw that? If you didn't know how to draw it, what's a good way that you could try to draw it? What's like the very first way when you started learning how to graph a function? What's the very first way you learned how to graph a function? A table. Just create a table of values and plot points that way. We're going to do it using transformations just because we're together and I want you guys to get practice doing it that way. So normally the absolute value function looks like this. Don't write this down yet. I'm going to do it with you guys. So normally the absolute value function looks like that, correct? What does this 4 do to it? It shifts it up 4. So it's almost like it's up here at 1, 2, 3, 4. And now it's up there. What does this negative 2 do to it? What does the negative do to it? How about that? It flips it upside down. And what does the 2 do to it? Good, it stretches it by a factor of 2. So the final graph looks something like that. That's what it should look like. Alright? Now what I want you guys to do is I want you guys to find the exact point. So actually draw a good graph of that on your paper and it should look something like this. Whether or not you want to plug in points, so if you want to plug in 0, 1, 2, and actually plot points that way, that's fine. Or whether or not you want to do it by transformations, that's fine as well. But it should look something like this blue graph when you guys are done. So only do it from 0 to 5. We don't need the negative version of it, but we do need from 0 to 5. So plot the graph from there to there. Alright, so when you're done, it should look something like this. It's because we only care about from 0 to 5, the other side would have gone down like a V on the other side, but we don't care about that. So we only care about this part right here. So notice that I shaded in blue the area under the curve between 0 and 5. What's the area of this little teeny tiny blue rectangle here?
4.
Good, it has a base of 2 and a height of 4. So 4 times 2 is 8, and it's a triangle. So, I'm sorry, I said rectangle, didn't I? It's a triangle, so it would be half of that, which would be 4. So the area of that is 4. And what's the area of this bigger triangle over here? What's the base from 2 to 5? 3. And what's the height from 0 to negative 6? 6. So 6 times 3 is 18, and 18 divided by 2 is 9. So this one is 9, and it's negative because it's below the x-axis. So what is 4 minus 9? Negative 5. So, absolute value of functions do not appear on the AP test super often, but when they do, I suggest just drawing them and figuring it out that way, just because it's a lot easier than actually thinking about it in terms of an equation. You'd actually, if you wanted to solve this using an integral, you'd have to split it up into two separate equations using a piecewise function, and then integrate both of them and figure out which one you're looking at, so on and so forth. So in my opinion, it's probably just more work, and it's probably easier just to draw a line and figure out the area using the triangles. And it's probably a more visual way, makes more sense to you anyway. So that's the way that I would approach this if I were you guys. All right, as far as this lesson, as far as the fundamental theorem of calculus is concerned, this is where we're going to stop. When I was looking at the videos that I posted up last night, I saw that not very many people had started watching them. Okay, so obviously you know this and I know this, but I'm not your mom, so I can't like sit there at your computer with you and make you watch videos. However, I again will reiterate how strongly I feel about you guys starting to watch them now and watching them early so that you guys have time to study them, okay? I've put 6 up there so far. So I uploaded 3 yesterday afternoon, and then I uploaded 3 more last night. So there's 6 total on there. There's 2 more that I need to upload, and I'm going to upload them today. So you guys will have all of them by the end of today, and you need to study them before Friday because all of them are fair game. Let's recap what Friday looks like. How many FRQs do you have to complete on Friday? 1. Do you have to complete it by yourself? No, you can have a partner if you want to, or 2 partners if you want to. So 2 or 3 people. Are you allowed to use notes? Yes, you can bring whatever notes you want. So I suggest taking good notes on the videos and understanding them so you guys can get help on them. How long do you have to complete it? The entire period on Friday. So I know that it's a pep rally, but you have the entire period on Friday. If you already know now that you're not going to be here, you need to plan on coming to tutoring the following week to do it then. All right? Watch those videos, study those videos. I'm here for tutoring today and Thursday, so ask me questions, and we'll be good to go. Sound good? All right.